Today we will learn about recurrence relations and Master's theorem. Recurrence relations and Master's theorem. Right? Recurrence relations and Master's theorem. For a recursive algorithm, the there is a sequence of a function. Okay. So to know the time complexity of a recurrence algorithm, we use Master's theorem. Right? The recurrence relations can be shown like this: Tn equal to a t n by b plus fn, where a greater than equal to 1 and b greater than 1. So we need to know the definition of different terminologies. Here n is the size of input or size of the problem. Right? Second, so what we do, we first break the problem in a number of sub problems. So A is the number of sub problems. Right? And n by v is the size of sub problem. We assume that every sub problem has same size. Right? And fn, this is the cost of work done outside the recursive call. Cost of work outside recursive call. So in Master's theorem, three cases can happen. Case 1, if fn is equal to big O n to the power log b base a minus epsilon for some epsilon which is greater than 0. Right? Then we can say that Tn equal to theta n to the power log b base a. Case 2, this is not fx, this is fn. Fn equals theta n to the power log b base a. Then for obviously epsilon greater than 0, then we can say Tn, this implies that Tn समान Tn equal to theta n to the power log b base a into log n. Right? Case 3, if fn equal to omega n to the power log b base a plus epsilon, for epsilon greater than 0 of course, then Tn equal to theta fn. So we learnt about three types of case in Master's theorem. But Master's theorem doesn't work for every algorithm. If Tn is not monotone, then we cannot apply master's theorem. So limitation 1, if limitation we cannot apply for Tn is not monotone, or only works for Tn is monotone, only works if Tn is monotone, and this function fn, it must be polynomial. Fn must be polynomial. Another is, here a is a constant, number of subproblems is a constant. If a is not a constant, then we cannot apply this. A must be constant. These are the limitation of the master's theorem. Thank you for seeing the video.